Hi, so I just wanted to give a quick demo of how you can use the microbit as an activity tracker. And this is a resource that we've developed and tested. In fact, we tested this on a live TV show. We had two presenters wearing microbits tagged on their legs with a little Velcro strap. And at the end of the show, we revealed how many steps or movements they'd made, and the person with the lowest number was slimed, and we can verify that the numbers were correct for various reasons, resilience built in. So let me just quickly demonstrate this. So here's a microbit. It has this little yellow 3D printed battery pack clip that holds the battery pack in place. It's got a Velcro strap that you can put around your arm or your leg, and then you plug the battery pack in, get an X because you haven't started yet. You press the A button, you get a tick, so you now started the activity. You now shake it. You get this little animation on the screen. It basically flashes the screen every time you get to 10. So it has a low beep for 9, and then the 10th one is a high beep. And then when you want to see what the actual score is, you press the B button, and it flashes up 20. I'll give it another shake, flash it up. See, it gives you 21. So you can have any number of these on various parts of the body, arms and legs, and on your head and all sorts of things, and count activity of that part of the body. So that's the activity. It works. The general problem with it in terms of lots of movement is there's various ways that the microbit can reset. So if I accidentally press the reset button at the back, which you might do if it's worn on clothing, for example, it resets, and then what you get at the end is you get a 0, which would be really embarrassing. So we built in a whole load of resilience features to prevent that happening on a live show, and we're hoping that that will also be useful for delivering other movement-based activities. So one of the ways that we can stop resets, there's various modes of resets. So one of the modes is, in fact, two of them are to do with the battery pack. So if I show you a battery pack on the inside, these batteries can sometimes move sideways and they can sometimes bounce out. There's a little gap between, you can see that, between the lid and the batteries themselves. So we do have an option of a anti-reset device. It's a little 3D printed slip that goes into the battery pack like that. Just about fits in. So it pushes the batteries down, stops them sliding around. You pop the top on, just about goes on, and then you put that in our 3D printed battery clip, and then that stops both the sideways movement and the upwards movement of the batteries that might cause it to reset. So that makes it a bit more resilient. That might be enough for a standalone device. The danger still is that something accidentally presses the reset button. So if I start it, a few shakes, we've got 7, I reset it, you see you're back to 0 again. And you'll note that actually the X is there as a visual indication that the thing has been restarted. And the tick is quite good for film because it shows you that the microbit has actually been started and counting. So the other way that we can make this more resilient is to have a second microbit. In fact, we can have any number of microbits. For this activity, you probably only need one. So you power this microbit up. So this could be a microbit that's on another battery pack, for example. We've often worn these on our wrists, and then you can get a good 10, 20, maybe 30 meter range with the other microbit. So basically, it's a mirror of exactly what's happening on the microbit's measuring activity. So if I start the activity and then shake, you'll see the little animations going around on both of them. Okay, and I can even read the score out on this one. So that's 30, and we're just shaking it again. This will be a 31. Oh, there you go, 31. 31. Now, if either of those microbits reset, they both have the current score count in them. So if this particular one that is worn on the body resets, what happens is it talks to the other microbit and it gets the updated score. So you now notice that even though I reset this, in fact, let's do this really live. Let's take the battery pack out, so completely disconnected the battery pack. Let's say the battery's gone flat and you're changing the batteries. You see it's restored the score. So we've got 34 in there, and then on this backup microbit you see we've also got, press the button, also got 34. So that gives you this wireless-based storage area network, basically, that if this one resets, this one will restore the value. If this one resets, then it will restore the other one will restore the value. So depending on the amount of resilience you want, you can have any number of these additional microbits. But I think for this activity, we only need one on the body and one spare. The other thing you can then do, because you'll see that this extra microbit I'm connecting via a USB lead, is you can go into the make code editor. This is the make code editor. And in fact, you don't even need a program in there. You just, if you come back into, this is makecode.microbit.org, and just press the new project. I've done this already, but you press that and you get a new blank project. And when you plug in this microbit, this extra microbit, and you start to shake the other one, what happens is you get data coming through the USB lead. So now as I shake, you see what you get is you get the count on the screen. So if you were doing this on, say, two parts of the body independently, you could have 2 laptops, 2 USB connected microbits, and then 2 microbits on the body. The other thing you can do, this is on a Mac, I don't know if this is going to come out in the video recording, but you can arrange with the pinch zoom to zoom into the numbers. So you can get those, you could arrange for those to be on the screen, quite big. That's with the pinch zoom on the Mac, on the trackpad. The other thing you can do, Command-Alt-8. So the Mac has a Command-Alt-8, here you go. It zooms into where the cursor is. So I point the cursor somewhere, do Command-Alt-8, it zooms right in. And that's a really big number, so you can see that from a distance. That's in the accessibility settings, so I've got that turned on. I need to move the mouse out of the way, maybe. Let's move that over to there a bit. So you can get a reasonably large visual. Obviously, it's a little bit A-list on the screen because it's zoomed in, but so you can imagine having 2 laptops zoomed into the number, and then every time you get a shake in the microbit, the number goes up. Okay, let's just Command-Alt-8 to get out of that. I think it's Command-Alt equals, Command-Alt minus. You can zoom all sorts of levels with that. If the USB lead disconnects from the microbit, you stop getting data. And you plug the USB lead in again, and then after a few seconds, what happens is it reconnects, and you see the number, so it hasn't lost any numbers. Now, because the way this counter is working is it's always, every single radio message it sends has got the full count in it. It doesn't matter if you lose data. If you lose a few messages, once the next message comes through, you get the correct counter. Okay. The way to stop, if you wanted to stop at a particular point, the way to stop the activity, stopping is a lot harder than starting, actually, because of course the system is designed to be resilient against stops. But the way to actually stop would be to remove the battery pack of the microbit. And then shaking it will not do anything anymore. Okay, I think that's everything I need to say.